Hello, welcome back to BlenderSushi Live Noding. This video is gonna be like an addendum to the previous video, just to avoid the confusion. So basically, in the previous video, you see me kind of I have an object. Um, I have an object, and then I kind of applying the matrix transform a couple of times using the matrix apply, and I'm using the matrix in, and kind of like a piggybacking the objects, like something like this. And the final objects vector should be plugging back to the vertices, and the polygon plugin like that. So this is what I did in the previous live noding. This is actually working inside the objects. It's kind of like I said, it's kind of like deforming the actual objects, and I'm animating inside the objects. I'm doing it like that because it's kind of easier to understand. And if you want to make like a clone copy, you're using the matrix. But you could actually animate using the matrix itself, so the transform of the objects, like in this example. So in this example, I'm using the this is the objects coming in, vertices and polygon. I didn't disturb the mesh itself, but I'm using multiple transform in the matrix down there. So Sverchok has this ability to kind of doing the cloning, instancing cloning at the same time. So it's a little bit, can be a little bit more confusing, but once you understand it, so it's kind of makes sense as well. So in this case, I actually have 3 transform that I create. For the position of this object, I'm using a circle. The circle with 3 vertices. I can increase it. So now I have 6, and that way I have 6 duplication of the monkey. So that's for the position alone. You see the position, and with the position, I'm actually, in this case, I'm actually moving the circle as well. So I'm rotating the circle. That's why I have this monkey rotating as well, but each of the monkey is still kind of pointing in the same directions. I could actually rotate the monkey just by rotating each of the monkey here in the final matrix in. And let's see, I'm using the frame, and I'm gonna multiply the frame like 30. And now I'm rotating the monkey like 30 degree each frame, or maybe make it like 20 degree each frame. If I'm using animation nodes, I will be using the delay frame or delay time in order to offset each and every object rotations. In Sverchok, we use range float. We can use range float and add it with a frame number. I think this is correct way to do it. So now each monkey is kind of offset slightly in terms of rotation, but I realized that this is also somewhat a little bit slow if we are using the viewer draw. So if I'm using the bmesh mk2 and outputting the actual object, this will actually be a lot faster, I realize, which is quite interesting. I didn't know about this until today. Because normally whenever I'm thinking, okay, I'm gonna animate objects, I will use animation nodes, but I realized that we can actually do it using Sverchok as well. And you can see with the objects here, it's actually rotating and animating in 3D. So it's doing the rotations and it's moving the locations. Maybe can actually do the scaling as well. which means if I make this like 18 monkeys, for example, now each one of them kind of rotating with a slight offset, and I'm gonna save this. We could select all the monkey and file export Alembic, and let's say 200 frames and selected object only. Just export the Alembic. We can actually save these objects transform animations as Alembic. So there, like I said, with the Alembic cache, you either caching the you can cache the transformational animations, which is the object transform itself, and you can also cache the each and every object's deforming mesh. So mesh cache and transform cache for the Alembic. Currently, I think that's how I can understand it. Let's have a look at the result in a few seconds. So that's if you just a little bit extra information, because if you, but this is also quite interesting because I'm thinking that if Sverchok can animate the bones, and we can have two things we can control with the object transformations and the mesh, the motion of the mesh itself. So it can be really powerful, maybe a little bit complex to understand, but it can be beneficial as well. Okay, I finished the baking. File new, so it's empty scene. File, import the Alembic data. Let's go to desktop, find our SV animating, and now we have the transformation animation. If you check the objects, the object itself, the transform of the object itself doesn't seem to change, but if you look at the Alembic cache, instead of the cache in the mesh, instead of here in the modifier, instead of mesh cache, this is actually a transformational cache in the constraint that we can scale, and we can control the influence. So this is actually kind of like if you're animating using animation nodes, and you are instead of animating the vertices, you're actually animating the object transformational data, the object transform itself, and you're using Sverchok. You can do that using Sverchok. I didn't know about this until today, so I just want to make that clear. You can see the speed is with Alembic, it's already cached and it's really fast. And with Sverchok, of course, using the mesh data itself seems a little bit faster than if I'm turning this off and using the viewer node. Viewer node slow. Don't know why. I think it probably can be faster. But the B-mesh is a little bit faster, but probably just a little bit faster than animation nodes. So yeah, again, either you are transforming the object itself, which is just like if you're animating in the object level, the object mode, or you go into edit mode and then editing the mesh that way. So you have those two ways to animate. Always remember that. And Sverchok, normally with Sverchok, if you're basically, I think the easiest way to think of it, if I'm using the viewer draw, if we are using anything to do with the matrix, we are animating at the object level, and we can also create like a duplication of objects if we provide multiple matrix. But if we are animating on the top, just the vertices and the edge and the polygon, that's if you are just like if you are animating inside edit mode in Blender. So just make sure you understand those two differences. Yes, I guess that's pretty much for this live noding video. It's a very short, but I think it's really important. Thanks again for tuning in. I'll see you